We do have coffee in there.
What was that?
We do have coffee. Yeah.
There's an glial biology conference that some of you at this week, and then we've got a couple of days of class and an exam. So it's hard sometimes when you've been out of the routine to get back into it, but we need to get back into it fast. You guys this Monday. So hopefully we'll help with that today. We have a lot to go over. It's kind of bizarre to be given a gigantic topic that you took over the course of the year and whatever for 2 hours. But hopefully what I did is there are lots of references after we get out of the first part, at least just talking about general immunology. Most of this has come out of the primary literature because that's where the newest stuff is. So there should be good references for you to reference. I can't be at the review session on Friday because I'll be teaching the medical students. So if you have questions, email about that. I think they already made that available to you. I reminded them I couldn't be there Friday. I tend to, when you're a PhD, you get trained in how to give seminars, right? So lectures are sort of different. And so what tends to happen is I get into like seminar mode where I just talk. I talk fast generally without any nerves involved. So what I'm hopefully going to do is slow down today, but if I need to slow down, not rudely, preferably, that's not nice, let me know that I need to slow down. Because just default for me is fairly rapid speech. We do have a lot and it's kind of variable or you the outline, which we should find out, is we're going to go through some of the basics of immunology because it's hard to understand how the rules are different if you don't understand what the rules are. Players are. So we'll go through immunology, talk about methods. I've tried to sort of intersperse what some stuff that a researcher, not just the person in the class, would want to know. So we're going to talk about method. This is a little bit of a pet peeve to me, which would probably mean that it's something you should consider for the test. When people are in labs where they're using antibodies, where they're using the tools of immunology, and they have no idea what they're doing. It's just like another chemical like salt that they ordered from Sigma, and they're unable to think about it in a way that's useful for troubleshooting. So hopefully we'll sort of deal with that a little bit. It's just a couple of methods that I like, that are cool, that you use a lot, most likely, in most labs you're in. We'll talk about neuroimmunology, which will basically just be how the brain is different, what the rules are like, why it's a big deal. A little bit about multiple sclerosis. I do want to give a plug for Dr. De Silva's classes that I think will be next semester. This is a whole semester on what you're getting a tiny little vignette about. And she does a really good job of mixing clinical and basic science into that. So if I don't make you never want to study immunology again today, then you might want to think about that. And then I've done a lot on the neuro therapeutic side with immunology. So if we have time, we'll talk about ways that you can use the new rules in the brain to fix the brain. So most of the slides from the part on immunology came out of Janeway's immunobiology book, which I think is still Janeway. Maybe Janeway died. It is probably the best textbook I have. I have a lot of textbooks. In that the figures, a lot of times textbooks try to give you everything in words, and the figures are really helpful in understanding what's going on. You have a lot of analogies and abbreviations in immunology, CD40 and CD68 and CD86, and things that bind don't always match up in number, and the book is really helpful. So it's in the library. I scanned like most of the first chapter, I think, put in here. We're giving a very cursory glance at things, but hopefully it will be useful. So the immune system has its own sort of circulatory system. It utilizes the circulation to get around. It's this highway, but the places where it does its business are out of the circulatory system and in the lymphatic system. And you have, in the lymphatic system, you have primary, and you have your central, and you have peripheral organs. So the central organs, you've probably already heard about in other scenarios, are the places where you generate the cells of the immune system or you mature them. So we've got the so you've got the bone marrow and the thymus are the places where we generate the cells, and then the thymus is where T cell selection happens. The rest of the organs, so the lymph nodes, the spleen, places where the red blood cells are destroyed, are the places where you have interactions, but peripheral and spread out. And you've got lymph nodes throughout the body, particularly around the gut, because that's the place where you would have a really high risk of things coming into the body that could be damaging. So all of the cells that are involved in the immune system are from the same precursor, so pluripotent hematopoietic stem cells. You always hear about people using these. They want to be able to turn them into new hearts or brains or whatever. From your stem cell, you get red blood cells, you get platelets, and you get all of the immune cells, both of the myeloid lineage, which is mostly innate immune effectors, and the lymphoid lineage, out of the same stem cell, which is pretty great. It makes it a very useful tool for researchers as well as for keeping it alive. So there are two wings of the immune system, the innate immune system and the adaptive immune system. We're going to talk about both of them. And more than you being able to memorize what a mast cell does, what I would like for you to be able to understand is the importance